Hey, it's scenario 0121773 of Magenta Maelstrom, and today we are going to do we're going to be talking about extractions, well, how to extract iron and aluminium, so electrolysis and oxidization and reduction, which is one half easy, one half good. We're going to start off with the easy half, which is extracting iron. The question is explain how to extract iron plus aluminium ore, but that's not important until we get the general idea of oxidization and reduction in our heads. So we're going to do oxygen. I'm going to do the word symbol and the non-word symbol, because just for those that understand, that would, well, it doesn't matter about understanding. I mean, it does matter that you understand, but I mean that, like, so like that, those that want to see word, so like if they ask for the balance, well, not, yeah, balanced equation, I'll also do, which is going to be hard. Iron which is iron ore, and that shouldn't be, I've just remembered that shouldn't be oxygen there. That should be carbon. So C plus, that's not meant to happen. Arrow, remember, never equals. So iron ore is always oxygen that's with iron that's with oxygen, basically. That's the simplest way to put it, really. And the answer is C. And we'll do red as well. Oh, and we're going to balance it as well, but we're going to say balancing till after we've done the and iron. Plus iron. So it's basically carbon plus iron oxide creates the product carbon dioxide plus iron. And now here's where reduction and oxidization will come in. Green I am going to do is oxidization. So remember that carbon is oxidized, carbon oxidized, C is oxidized. Basically, oxidized means that the oxygen comes from one thing and is placed into another. Basically, it's kind of like a jigsaw puzzle. Like, it's a piece of carbon that's missed that needs the iron, I mean the oxygen. So the iron oxide is willing to take its carbon, I mean its oxygen off and give it to the carbon, but only because they are burnt. And basically, when they're burnt, when the iron oxide is burnt, the carbon, also known as coal, when they're burnt, is placed into the oxide is placed into the carbon. And now blue is going to be my reduction, which I'm going to do on the word equation. Iron is reduced that's where reduction takes place, where something loses iron from its, oxygen from its original state, and it's placed on into another thing. But that's the main answer. That's the how to extract iron. You gotta, well, that's all that we need to know on, that's oxidization and reduction. So I'll put that down in a mental note on the side for the remainder of the video. I'm gonna do the symbol because I'm just lazy right now. And iron oxide, remember always oxide, because before it's reduced into iron, you have to by reducing it, you take away the oxide, so it has to always, before it's reduced, it'll be iron oxide. So when, by saying the iron oxide is reduced, that means that the iron oxide has lost its, reducted, maybe, reduction. I'm sure it's reduced or reducted. I'm not sure. We'll do reduced. To get your science teacher to answer that for you, because I can't remember if it's reduced or reduced or reduction. I know is what is reducted, but I'm not sure if that sounds right because it doesn't sound like a real word. And electrolysis, that is very hard to explain. So we're gonna get a new page. Because like I'm using paint, because that's actually much easier than using paint.net. So if we begin, we'll use that is a vat of water, and we have our carbon cathode. Cathode is always minus, and anode. Cathode. Remember, an sounds like add. Well, and cats, it's the other one, so it's got to be obvious. Subtract that. Now I've got it. Remember, cat is in a like subtract. Like at the end of subtract is cat basically. And the next thing that I'm going to do is, that's basically how electrolysis is drawn out. That's the simplest way to put it. And I'm gonna explain what electrolysis means. We get red. Cis means split. This is this is a very important thing, because like they do actually question this in the exams. And electricity. So the answer would be, so if they were to ask you explain what does electrolysis mean, it means splitting a product with either direct currents, I believe is the correct terminology. I just have a check. Yeah, explain with direct currents. currents slash electricity. They don't mind electricity, but direct currents is much more scientific. So splitting a product with direct currents, that's basically electrolysis. And if we put that in the other page, just so that you don't remember, is splitting with direct current slash electricity. So the question was aluminium. We would put, because we'll use orange, AO. That's the compound, AO. Basically, the easiest way to remember is hydrogen is always a positive, so oxygen will have to be negative because H2O. So that would mean aluminium would have to be a positive, wouldn't it? Aluminium, if we just get blue, it's always going to be positive. Think about it. So that would mean that oxygen would move on to the anode. That's because basically the way I see it is, if it's, I understand that like if it's a minus, it'll always go into the plus, because I think the easiest way to remember is opposites attract. So if you get aluminium, where would aluminium go? That's right onto the cathode. So I'll just place it on the cathode. And if you do the actual test, you'll notice that on the cathode, aluminium will start to form onto the cathode. Okay, but the problem with electrolysis, if we just go down here, if they ask what the problem with electrolysis is, it's very expensive. The simplest way to put it, like you won't believe, like that's why they will tend to use the carbon thing. We'll do this in red. Electrolysis is expensive we're gonna remember that in the brackets, just remember that. And that's the general, you've got to understand that carbon is oxidized into carbon dioxide, iron oxide is reduced into iron. Electrolysis is splitting with a direct current slash electricity, and electrolysis is expensive. Also opposites attract with electrolysis. And they're the key points about electrolysis and oxidization and reduction, which are the main topic of this video. But now we've got to answer the question, explain how to extract iron plus aluminium. I think we'll do iron oxide. You use carbon So you use carbon to extract iron oxide. This is because iron is below carbon on the reactivity series. I would put that down, but like, you know, it's too much effort. But like you'd probably know that iron is below carbon on the reactivity series and aluminium is above. That's just the key. Like you've got it. That's just general knowledge in science. But like by knowing that, they'll have to use carbon because there's more. Pretty much the simplest way to put it is there's more to give up. There's less to give up. If basically let's say oxygen is a girl and carbon is a boy that wants oxygen, and iron is the boyfriend of oxygen. If the oxygen prefers carbon, it will just go to carbon because carbon has more than iron. If you understand that, it may be. Now the next part is to remember that aluminium oxide is aluminium is above carbon on reactivity series, so aluminium oxide needs to electrolyzed. That's basically the simplest way to explain it. You can, if it's a 6-mark question, then you'd probably add these details, and if it explain probably the con of electrolysis and the pro of iron oxidization and reduction. But they're the key points, remember that. So if we remember this, it may be a bit difficult to understand now, but that's what the idea was. So yeah, this was electrolysis and oxidization and reduction and electrolysis. So hopefully you understood that video, and bye.